Hello everyone and welcome back to this brand new lesson. In this lesson we are going to talk about how to create the interaction system inside of our game. So let's start by first of all creating a brand new folder, and this folder is going to be where we're going to store all of our scripts. So let's call this something like scripts. Alright, so we are going to create two scripts. The first one is going to be the interaction system. And the next one is going to be the script where we're going to store all of our interaction data. And it could be called something like raycast data, for example. So first of all, let's go into our scripts folder and let's create a brand new subfolder, which we can call something like mono. This is where we're going to store all of our mono behavior scripts. And then let's create another folder where we're going to store all of our scriptable objects. Alright, so let's go into our monos folder and let's create a brand new C# script. And let's call this script something like interaction system. Alright, so once this script has opened, we can actually start writing this script. So the first thing we need to do is we need to implement a couple of variables. So the first variable that we need to implement is going to be the camera, because whenever we're going to interact, we are going to cast a raycast to get the information about the object that we are interacting with. So we are going to need a camera to determine at which direction we need to cast the raycast. So let's first of all create a private serialized field, and let's say this is going to be a private transform, and we can call it something like a view camera. Alright, so the next thing we need is we need the interaction distance. So this is going to be a private float, and we can call this something like interaction distance, and by default we can put it something like 5. It doesn't really matter, we can tweak these parameters in Unity itself. And then the last thing we need for now is going to be the layer mask. So we need to determine with what kind of objects we want to interact. Obviously we can kind of interact with all of the objects, but we don't really need that because first of all it's going to be heavy on performance, and we don't need to interact with every single object. We only want to interact with an object that is interactable. And for example, objects that are going to be interactables are going to be something like pickups, or when we want to open a door or something like that. So all of the objects that has a function and we want to interact with this type of object. Alright, so let's create a brand new layer mask and let's call this layer mask something like layers to interact or to raycast. We can go into our update function and we can first of all create, first of all what we need to do actually is we need to create a brand new function that is going to return the raycast hit. So we can say raycast hit, and then we can give it the names to something like do raycasting. Alright, so the first thing we need to do inside of this function is we need to create a brand new ray. So to do that we need to say ray, then we can call it something like ray, and we need to say that this is going to be a new ray, and what the ray needs as a parameter is the position and direction. So where the ray needs to start and in which direction the ray needs to go. So the position that the ray needs to start is going to be the view camera dot position, and the direction is going to be the forward direction, so where the character is looking at. So the position needs to be view camera dot forward direction. So the forward direction is simply just the blue axis of the transform, which is simply just where the character is facing. Alright, so once we have a ray, we can then declare a brand new raycast hit, and we can call it something like hit, and afterwards we need to do an actual raycasting. So what we can do is we can create a brand new temp variable, which is going to be a boolean, and we can call this something like has hit. And then we can actually do the raycasting, which will return a state if either we hit something or if we haven't hit anything. And And the function that we need to use is going to be physics.raycast. And this function, first of all, requires the origin and direction. Pass in the ray because the ray already contains these two vectors, which is the position and the direction. The thing we want is we want to store all of our raycast information, and we want to store it into this hit variable that we just created. All right, so to get this information and store it into this variable, we can say something like out hit. So the couple of more things that we need to pass into this raycast function is first of all the distance, and the next thing is the layer mask. So the distance is going to be, of course, the interaction distance, and the layer mask is going to be layers to interact. And that's all we need to do. So now we are going to do the raycast, and we are going to, well, first of all, return the state, the result of our raycast. Either we hit something or we haven't hit anything. And we are also going to return and store our hit information into this variable. All right, so the very last thing that we need to do is we need to check, first of all, if we hit anything. We can say if has hit. And if we have hit something, we are going to return the hit. But if we haven't hit anything, we want to return, well, nothing, which is null. But as you will notice that we can't really use a null because a raycast hit is not a nullable value. To fix that, we can add the nullable operator. And to do that, we simply need to add the question mark. And this will turn the raycast hit into a nullable value type. And now we can return the null. So what we need to do now is we need to go back to our update function. And the first thing we need to do is we need to, well, first of all, we need to get the raycast hit information. So we can say raycast hit, and we need to add this nullable operator because this is what this function returns, because it will return either hit information or a null value. So we need to make sure to add this nullable operator as well. And then we can call this something like hit, and what we are going to store into this temporary variable is we are going to store whatever this do raycasting function returns. All right. So the next thing we need to do is we need to check if this hit contains a value. So to check that, we simply need to say if hit has value. If it contains a value, we want to update the raycast data information. If this well, variable does not contain any value, we want to reset the raycast data file. So first of all, of course, we need to implement this script. So let's go back to Unity. Let's go back to scripts and scriptable object. And let's create a brand new C# script that we can call raycast data. We can then open up inside of our Visual Studio. All right. So this is going to be kind of like a storage, a file where we're going to store our raycast information. So first of all, this class is not going to derive from mono behavior, but instead from scriptable object. And we not really need these functions, so we can just simply delete them. And all right, so right now we can implement a couple of variables. So the first thing we need to determine is the hit transform. So let's say public transform, and we can call this something like hit transform. All right, so what we want to do with this variable is we want to be able to get the variable from other classes, but we don't want to be able to set the variable. So to do that, we can use something that is private set and get. So private set is going to make sure that this variable is a private setter, so we can only set the value to this variable inside of this class. And get is going to make sure that we can get this, well, transform from other classes. So just like a public variable. All right. So the next thing we want to implement is going to be the public raycast hit. And just like we are doing in here, we are making sure that this is a nullable type. So we need to make sure that we add this nullable operator as well. And we can call this something like hit. And just like we did before, we say this is a private set and get. All right, and this is all the information that we want. So the next thing we need to create is a new function, which is going to be called something like update data. And this update data method is going to update the data inside of this class. So the parameter is going to be the raycast hit. And so let's say raycast hit. Let's add the nullable operator and let's call this something like hit. And so what we are going to do inside of this function is we are simply going to set the values. So first of all, let's say the hit transform is going to be equals to hit dot value dot transform. And then the last thing is, of course, we need to say that the hit is going to be equals to the hit. All right, and that's pretty much all we need to do. So the next thing we need to do is we need to create a brand new function again, and this function is going to be called reset. So this is gonna be the function that will reset the information. The only thing we need to do inside of this function is simply reset these values and set them to null. So let's say hit transform is going to be equals to null, as well as the hit is going to be equals to null. And that's all we need to do inside of this function. So now we can go back to our interaction system and we can go back to our update function and we can actually implement and call these functions. All right, so the thing we need to do here is if we have a value, we want to update the data. So we simply need to say, actually, before we do anything, we need to grab the reference to our raycast data. So let's go here and let's say serialized field private or raycast data, and let's call this something like data. And then what we can do is we can say data dot update data, and then we can simply pass in the hit. All right, so the next thing is, of course, if this hit does not contain any value, we want to reset this data file. So let's simply say data dot reset, and that's all we need to do. But the problem we are going to get right now with this is we are going to constantly check and constantly update or reset this data file, but we don't really want to do that constantly. We want to do it once and then not do it again. So to do that, we can implement first of all a brand new function inside of our raycast data class, and this function will return the boolean, which will pretty much going to check if this new hit that we are going to send is going to be the same hit that is already stored inside of the data file. So we are going to, first of all, let's create a public function which is going to return a boolean, and we can call this function something like is this new object, and what we want to send as a parameter is the transform. All right, so inside of this function, so the first thing we want to do is we want to check if hit transform is equals to null. So if hit transform is equals to null, it will mean that, of course, this new hit is, of course, a new transform because there's nothing stored currently inside of this data file. So we can simply return true. Then we need to do another check, which will check if hit transform is equals to the transform that we send as a parameter. If that is the case, we of course want to return false. And this will pretty much going to mean that this new transform that we send in is already stored inside of this data file. So it's not a new hit. And the very last thing is, of course, we need to return true. So if this is, well, not the case. If the hit transform is not equals to the transform, we're simply going to return true. All right, so now we can go back to our interaction system, and inside of here, we can do a new if statement, which will check, first of all, if data dot is this new object, and we can pass in as a parameter hit, value, and transform. So this hit values transform, and if this is indeed the new transform, we are going to update the data. But if this is not a new transform, we are simply going to do nothing. All right, so the very last thing we need to do inside of this update function is, of course, if this hit does not contain any value, we want to only reset it once. So first of all, we can check if this data file contains the hit transform. So if data contains hit transform, so if hit transform is not equals to null, so that will mean that we haven't actually resetted the data. So we can then reset the data, and then it will make sure that this hit transform is equals to null, and the next time we are going to do this check, we are not going to reset the data again. So the very last thing we need to do is we need to make sure to reset the data file at the start of the game. We want to make sure that whenever we start the game again, the data is resetted. We don't want to kind of keep this data whenever we exit the game. We want to, whenever we join the game, reset the data, and then we kind of start collecting new data again. All right, so this is pretty much it with this interaction system. All right, so the very last thing that we can do actually is we can kind of optimize this script just a little bit. And what we can do is we can wait a certain time before we do a raycasting. So currently we are going to do a raycasting every single frame. So what we can do is we can wait for a certain amount of frames before we start doing a raycasting. So the way we can do this is we can do, first of all, an if statement. And what we need to access is we need to access time.frameCount. So we need to simply say time.frameCount, and then what we need to use is this operator, which is the modulus operator, something like 4. And if frameCount divided by 4, and if the remainder is 0, then we are going to do the raycasting. So to simplify, what this actually does is it will simply wait 4 frames before doing a raycasting again. So we can put in something like 6, and that will mean that it will wait 6 frames before it will do another raycasting. All right, so we are back inside of our Unity. All right, so now we can assign some of the references, as well as we can configure some of the settings that we exposed, like interaction distance, as well as what layers we are going to interact with. So first of all, we need to, of course, the data file folder. We can create a brand new data file, but we actually cannot do that because we haven't actually created an asset menu, and the asset menu is pretty much going to allow us to create the scriptable object. So to create an asset menu, you need to add the attribute, which is pretty much called create asset menu. And what we can actually also configure is we can configure the file name as well as the menu name. All right, so now we can go back to Unity and we can actually create this asset. And to create this new asset, we can simply need to right click, go to create. Then we will have this sub menu, which is game. And then as you can see, we have this new raycast data. All right, so now we can go back to our FPS controller and we can assign this new created data into this script. And then the last thing we need to assign is simply just our camera. So we can simply drop our first person controller camera. And that's all we need to do. So now the last thing we need to do is, of course, we need to create, first of all, a brand new layer. And the layer we are going to create is going to be interactables. Or we can call it something like interactable. So we created a brand new layer, and we can now go to our script, and we can see that we only want to interact with the object that is layered as the interactable object. All right, so once we assign all of the parameters and all of the references, we can actually drop some random object and tag it as an interactable to see if we can actually interact with this object and get some information about this object. So let's create a brand new cube, for example. Let's position it somewhere like here, and let's first of all, let's make sure that this object is layered as the interactable with the interactable layer. So this will make sure that this object is now interactable. So if you're going to play this game right now, we're not really going to see any visual feedback or anything like that. So to kind of test this at the moment, what we can do is we can debug the information of the new interactable object. So every time we are going to interact with an object, and whenever we are going to update the data, we want to debug the information about this new object. So what we can do is we can simply say hit transform dot name. So we are going to debug the new hit transform's name. All right, so if you're going to go near our object right now, as you can see, we have interacted with the object, which is the cube. All right, so as you can see, everything seems to work pretty well. So let's just, for testing purposes, let's create a brand new object just to test if everything is truly working. And let's call this object something like Kate, for example. Doesn't really make sense, but it's just for testing purposes. So I think it's just going to be okay. So now let's go to this new created object. And as you can see, it says now Kate, which is the name of this object. And now if we are going to go to this object, as you can see, it says the cube. Currently, we are kind of interacting with these objects for quite a long distance. So we can kind of tweak these values and say, for example, we only want to interact with the object if the interaction distance is 2.5 or less. So we can now go back to the game and let's see if this is now going to be better. So let's go to this object. As you can see, we have to be somewhat in this distance to be able to interact with this object. Alright guys, so this is pretty much it for this tutorial. We have created the interaction system as well as the data file where we are going to store all of our interaction data. So in the next lesson, we are going to kind of display this visual feedback by creating a messages manager. And the messages manager is going to be able to help to kind of display the visual feedback on our screen. But like I said, for this lesson, it is all we need to cover. So thank you very much for watching, and I'll see you in the next video.